Hello everyone. This is, well, technically the second webinar, but actually the first one was cancelled. And we had an issue with, well, anyway, we had an issue. Apologies. So effectively, this is the first webinar, but I decided not to change the numbering. So it's called the second webinar. I'll do the first webinar again in 2 weeks' time. So we'll do physics again. Well, we'll do physics. So today's maths. We're going to talk about quadratics. But before we start, I would like to introduce COMPOS a little bit for you. So what are we trying to achieve with COMPOS? So, for example, if you want to become an athlete, you don't decide at the age of 16 that I want to become an athlete, and then you take athletics A level, and then you go to athletics university. That doesn't happen. To become a really good athlete, you have to start when you're probably 6 or 8, maybe 10 for some sports. And then you train every week for many hours, and then you become really good. With physics, somehow it is expected that you take physics A level and then you become a physicist. No, it doesn't happen. You have to start the same, just like an athlete. You start early, maybe not 10, but 13, 14 is a good age to start your physics journey. And then you train hard every week for several hours a week, and then you become really good. And that's what we provide. We provide this sort of training in physics, just like you would do an after-school football club or after-school gymnastics, the same way you do after-school physics for, yes. And where's my screen? I'm going to share my screen. By the way, you all have access to this whiteboard, and you can look at it at any time you like. So I'll copy that and put it in the chat. Where is the chat? Chat is here. Yes, so at any time you can access this whiteboard. It's also published on our website. Let's see where it is on our website. So if you open the COMPOS website, about COMPOS webinars. So this is the timetable for webinars. So today is the quadratic function, and it Maths 01. And you have the playlists. Please check this out because I have recorded webinars for all the topics, and you can click all your 10 webinars, and that takes you to the playlist, all the topics. So quadratics, we've already done that last year. Then you can check out the whiteboard. This is this link. This is the whiteboard. Okay. That's once. So COMPOS, we have sort of 3 branches of COMPOS. Well, they're technically 2. So the main program, the COMPOS main program, is for state school students. State school UK students. Then what it involves, the main program, it involves 10 assignments, which are mandatory. So 10, that means 10 physics and 10 maths. Then we have webinars, 3 per month. So not exactly every week, but 3 weeks, then 1 week off, 3 weeks, 1 week off, 3 weeks out of 4. Then we have, 2 per month, 2 webinars per month. That's optional. Then you have tutorials. This is 3 per month, and this is mandatory. And there's homework, of course. So the 10 assignments is your homework, and this equates to approximately 3 to 5 hours homework every week. week. Some people work faster, some work slow, but that's the average. I think that would be the middle 50% manage to finish it 35 hours every week. That's the kind of training we're talking about. In addition to that, there's the webinar, which is optional because they are recorded. This webinar is recorded. Tutorials are mandatory. You have small groups, so groups of 8. Groups of 8 students. Cool. COMPOS Foundation is the same as the main program, but it is for private school students, private and overseas schools. Now, these students pay a small fee, which only covers the cost of tutorials and the administrative work which is required, so we don't get any profit. We just use this money to pay the costs because our sponsor our sponsor pays for the state schools, but they don't pay for the private school students. So basically, private school students pay for themselves, and it is at cost, and I think it's about £25 a week. But I'm not doing finance at the moment, so you can check our website. And it is the same program. Also, 10 assignments. The follow-along program is the COMPOS Lite, if you wish. It has 10 assignments, which are optional. And you don't have to do them. And you have webinars. Webinars also optional. Now, you can join the follow-along program in October if you don't want to do the main program, or if you didn't get into the main program, for example. We don't know the passing grade for the main and COMPOS programs. The passing grade is the same for both programs, but we want it to be 50%. But we have 1,000 places. So if 1,000 students do better than 50% on the entrance exam, then we'll have to increase the passing boundary, unfortunately. But yeah, we don't know the passing grade. Normally it's 50%. Last year it was higher because we were limited with the number of places. This year we have 1,000 places. So hopefully we get everyone who gets above 50% on the entrance places. Oh, no, sorry, 1,000 places. That's for the main program. 1,000 places for the main program, because that's how much money we have in COMPOS Foundation. Well, we don't know, but I think anyone who gets above 50% would probably be eligible to join. Okay, cool. So approximately above 50%. Now, today we don't have the chat available, but we have the Q&A. So if you don't see Q&A, you can press more and you will see Q&A. And if you have a question, you can ask me and I will answer it. Or Arian is one of our tutors today, and he can answer some of the questions as well. Thank you. Perfect. So let's start. So we start quadratics, not just quadratic function, quadratics and quadratic equations. And you probably have done, probably have done quadratics in school, some form of quadratic equations. I will introduce you to hopefully some quadratic equations that you haven't seen before. Okay. Right. We have a question. We have some questions. Sorry. I'll answer them. What happens in the COMPOS tutorials? Yes, Arian will answer. The mandatory tutorials, yes. So it's a small group tutorials. They're online, and you have these are online tutorials in a groups of 8 with a tutor, typically a university student. You would have probably an Oxford student running the tutorial. What if less than 1,000 people sign up for Compos main program? It's highly unlikely, but yeah, then we have lower spaces. We wouldn't take anyone scoring below 50% unless there are special circumstances. Okay. Are we to check our answers with math solving tools? Ooh, that's a good question. Okay, check our answers with math solving tools. I don't have an answer for you. Because math solving tools have become so sophisticated nowadays that yeah. Yeah, by the way, about math solving tools, so we have really sophisticated math solving tools. Potentially, you could someone could potentially cheat and get into the program by doing that. I want to say that this doesn't really won't help. Yes. So if you are students who follow the program get really good results. And if you complete the program and you get a certificate at the end, you're expected to be that good. So if you got like, I don't know, 80% in every tutorial, and you did it by, I don't know, copying it from someone or cheating by any other method, like using AI or something, then you come to the university interview and they ask you a question, like a reasonably difficult question, and you can't answer it. There was like, so you did COMPOS, but you can't answer that question. That's very weird, right? So this will work against you effectively. So yeah. Your solution cannot be based on math solving tools. Yeah. Are we allowed to use Desmos? Yes, you can use Desmos, definitely. You can't base your solution on Desmos. You can check your answers with Desmos. Well, it'd be higher score you get, the more likely you get in. Yes, more higher score you get, the more likely to get in. Yeah, doing your own research. Yes, checking your answers. Checking your answers with Desmos is definitely fine. Typing it into ChatGPT, I'd say probably not. Okay. Right. There's lots of questions. I really want to do some maths. Can we let Arian answer them? And I will get on with some quadratics, and then at the end I'll leave some time to answer your questions, which are left. Okay. Right. So the first thing I want to do is solving by inspection. So hopefully you can see my screen. Which screen do you see? I really hope it's the correct one. Yes, you're seeing the correct screen. Right, solving by inspection. So here we have some quadratics, some really easy quadratics. So x squared equals 0. So obviously, you don't need to know anything about quadratic equations to tell me that, well, yeah, the only number which when squared is 0 is 0. So x is 0. Basically, the question is, which number fits? The second one is not so obvious because, of course, you have 1, but also -1. -1 also fits. And Right, and these are the only two, because no other number when squared is 1. X squared equals x. Ooh, nice. Which number is a square of itself? Yeah, you want to ask. Which number is a square of itself? Well, obviously 0. Yes, because 0 squared is 0. And also 1. 1 squared is 1. Equals 1. Minus 1 doesn't work because minus 1 squared is not minus 1. So these are the only two options. So this is called solving quadratics by inspection. So you just look at the equation and you think, which number could possibly work here? So x squared is 13x. So a number squared is 13 times that number. Well, 13 squared is 13 times 13. So x equals 13 is an answer. What's the other answer? Well, you probably can guess that it's 0, because 0 squared is the same as 13 times 0. So we're just guessing. Well, not guessing. It's more like an educated guess. It's called by, yeah, what's this? By inspection. And then you move to this. But if you check that these two equations are actually identical. Oh, no, sorry, these are not identical. Oh, apologies. That's not what I meant. Yes, like this. These two equations are really the same equation. So if you just say, replace this bracket with the word something, something squared equals 17 times something. And you can see that, well, it's the same as this one, right? Just except it's with a different number. So of course, that something is equal to 17, or that something must equal to 0. Right? So in other words, x plus 2 is 17, or x plus 2 is 0. And here x is 17 minus 2, that's 15, or x equals negative 2. And you can check those. You can check, and it's always a good check that 15 plus 2, 15 plus 2 squared is 17 times 15 plus 2. Well, definitely, yes, that is true. And minus 2. So minus 2 plus 2 squared equals 17 times minus 2 plus 2, which is also true because this is 0 and this is 0. Nice. This one. Okay. So, well, what do we see here? Well, what we see is something squared is something else. Oh, okay. Is 7x plus 4 multiplied by something. Well, obviously that something might be 0, right? Well, if 3x minus 2 is 0, that is a solution, definitely. What's the other option? Well, the other option is that this has to be equal to something, or 7x plus 4 must equal to 3x minus 2, right? Therefore, here 3x equals 2, x equals 2/3, or 7x. So you do minus 3x, so 4x equals minus 6. X equals, you divide by 4. So you divide by 4. And then that is minus 6 over 4. So x is minus 3 over 2. So you have two solutions. Okay. Right. this one. Well, when you see something confusing, you want to make it less confusing. So what if it was something really simple, like a squared equals b squared? When does a squared equal b squared? Well, if a uh, if a equals b, or well, if you think about it a little bit more, you will realize if a equals minus b. Because if a is minus b, yeah, you can see that minus b squared is b squared, because the minus b times minus b is plus b squared. Right, so you have two possibilities. So if something squared equals something squared, that means either they are the same or they are opposite. That means 4x plus 3 equals 2 minus 7x, or 4x plus 3 equals minus 2 minus 7x. And then you can add 7x to both sides. So 11x equals negative 1. X equals negative 1 over 11. That's the first solution. Or, well, 4x plus 3 equals, you open the bracket, so minus 2 plus 7x. So 3x equals 5. X equals 5 over 3, 5/3. And this is the solution. Okay. So hopefully that makes sense. And this is solving by inspection. The next thing I want to introduce is the Vieta's formulae. Okay. So consider a quadratic equation. Consider quadratic equation. Ax squared plus bx plus c equals 0. Let x1 and x2 be the roots of apologies. I think I've um, okay, let's not do it this way. Well, yes, okay, let roots of the equation. But we know that x1 is minus b plus square root of b squared minus 4ac. We know the quadratic formula, 2a, and x2 is minus b minus square root of b squared minus 4ac divided by 2a. And now you have, let's find x1 plus x2. Let's add them. So we have minus b plus square root of b squared minus 4ac divided by 2a plus minus b minus square root of b squared minus 4ac divided by 2a. And when you add them, you see that this bit cancels out and you get minus b, so minus 2b divided by 2a, which is minus b over a. Okay, that's an important result. Now we find x1 multiplied by x1. And we get minus b plus square root of b squared minus 4ac divided by 2a multiplied by minus b minus square root of b squared minus 4ac divided by 2a. Now we multiply this by, well, some people call it FOIL. I don't like calling it FOIL. I just call it expanding. And here. All right, so let's see what we get. We get on the bottom, we get 4a squared, of course. And here we get minus b squared, so b squared, then plus b square root of b squared minus 4ac minus b square root of b squared minus 4ac. And then finally, we get minus b squared minus 4ac. I'm just opening the brackets. And you see the middle terms cancel out. Open the brackets, b squared minus b squared plus 4ac divided by 4a squared. B squared minus b squared cancels, and we get 4ac divided by 4a squared. 4 cancels, a cancels, and we get c over a. And this important result is called the Vieta's formulae. The Vieta's formulae look like this. Vieta's formulae. That x1 plus x2 is minus b over a, and x1 multiplied by x2 is c over a. And you can use these to find the roots. I know in school you were probably taught to factorize, and this is very, very similar to factorization. I wouldn't recommend you using this method in a school setting. It might be slightly more confusing, but we feel it's important that you learn this because this method is learned in further maths when you do A-level further maths, which I encourage you to take if you like maths in the future, in 2 years' time. Okay, so let's try to do this using the Vieta's formulae. So we see that this is a quadratic equation, a equals 1, b equals 7, and c equals 12. So Vieta's formula, x1 plus x2 equals minus b over a, and x1 multiplied by x2 is c over a. All right, so that means that x1 plus x2 is minus b over a, so minus 7 over 1. So minus 7 over 1, which is minus 7. x1 times x2 is 12 over 1, which is 12. So we need to find two numbers which, when multiplied, they give you negative 7. Oh, sorry, when multiplied, they give you 12, and when added, negative 7. And the find two numbers which add to negative 7 and multiply to 12. And you can see that it is x1 is negative 3 and x2 is negative 4. That's it. We found the solution. Okay, let's use Vieta's formula for this one. This is a slightly sophisticated. So x1 plus x2 is minus b over a. So that's 5 over 2. The minus cancels. And x1 times x2 is 3 over 2. Okay. maybe slightly harder than you are used to, but it's still. Which two numbers, when multiplied, give you 3/2, and when added is 5/2? Well, actually, it's 1 and 3/2. X1 is 1, and x2 is 3/2. Check. 1 plus 3/2, that's 5/2. 1 times 3/2, that's 3/2. Works. Ta-da. So you see, you can solve quadratic equations. Well, you do need to be very good at arithmetics, but cool. This one. So x1 plus x2 is -8/3. x1 times x2 is 4/3. So two numbers which add to -8/3 and multiply to 4/3. Nice. I'm guessing 2 and 2 and 2/3. X1 is -2. X2 is -2/3. Check. -2 times -2/3. That's negative. Sorry, 4/3. And x -2 -2/3. That's 6. 6/3 minus 2/3 minus 8/3. Works! Yes! We've done it. We found. Okay, not always easy to spot. Okay, honestly, it takes some practice. But this method is very useful in some cases. Okay, so now you just have another arrow to your quiver. Okay. 3. Special cases. I love special cases. And you will learn that they're not so special after all. The special case is quadratics. So special case 1. Special case 1 is when you have a quadratic equation, ax squared plus bx plus c equals 0. So the special case is when a plus b plus c is 0. What does that mean? If the sum of coefficients is 0. If the sum of coefficients is 0, then the first root is 1, and the second root is c/a. And it's a consequence of Vieta's formula. You can prove that it is a consequence of Vieta's formula, but that's, yeah. How does that work? Well, example. X squared plus 3x minus 4 equals 0. So you can see that the coefficients are 1 plus 3 minus 4. 1 plus 3 minus 4, and that's 0. And that means that it's a special case 1. Special case 1. And it is x1 is 1, and x2 is -4/1, which is -4. That's it. Example number 2. 13x squared plus minus 27x plus 14 equals 0. Now you can see that 13 minus 27 plus 14 is 0. That means the first root is 1, and the second root is 14/13. Pretty cool, right? I hope you'll find it useful. Now, special case 2 is almost identical to the special case 1. Special case 2. Now, special case 2, if A minus B plus C is 0. So basically, you change the sign of the second coefficient. And if you get 0, then the first root is negative 1, and the second root is negative C over A. Okay. How does that work? So example, 3x squared plus 7x plus 4 equals 0. So you can see that it's not a special case 1, because 3 plus 7 plus 4 is not 0. 3 plus 7 plus 4 is not 0, but 3 minus 7 plus 4 is 0. That means it is a special case 2. And that means that the first root is negative 1, and the second is negative 4 over 3. Okay. Do we have a poll? Do you get this cases? Yes. No. Okay. Oh, let's check. I've never tried the polls before. Do you see? Oh, nice. Oh, very nice. I love it. Okay, so why am I saying that the special cases are not so special after all is because I've taken a random page from a GCSE book. This is just a solving quadratic equation by using the factorization method. So it's just a GCSE book for GCSE. And let's see if we can find any special cases. 1 plus 3 plus 2. That's special. That's not special case 1, but it's special case 2. So that is a special case. So that means that the first root is negative 1, and the second root is C over A, minus C over A, so minus 2. Okay. So this is a special case 2. Because 1 minus 3 plus 2 is 0. Right? So if you change the sign, it becomes 1 minus 3 plus 2 is 0. So that means the first root is 1. Second one, ooh, it is a special case. It's a special case 2. Because 1 minus 6 plus 5 is 0. And so that's x1 is negative 1, and x2 is negative 5. 3, 1 plus 7 minus 8. Ooh, that's a special case 1. The first root is 1. The second root is negative 8. This one, that's a special case 1. Again, so 1 plus 1 minus 2 is 0. So the first root is 1. The second root is negative 2. This is not a special case, 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 not special case 2. 2 minus 3 plus 1 is 0. So that means the first root is negative 1. The second root is negative 1/2. 2 plus 5 minus 3. That looks like a special case, but it isn't, because 2 plus 5 minus 3 is not 0. And 2 minus 5 minus 3 is also not 0. 3 plus 7 minus 2, no. 2 plus 1 minus 3, that's a special case 1. 1 and negative 3 over 2. No, no, yes, this is a special case 2. Minus 1 and minus 5 over 3. No, no, no. You can see about half. Okay, about 40% About 40% of questions are special cases. So it's not so special. Right. So there's 6 people who don't understand special cases. Well, let me just quickly reiterate. If you have a quadratic equation like 3x squared minus 4x plus 7 equals 0. It is a special case because 3 minus 4 plus 7 is 0. If you add these numbers and you get 0, that's a special case. And that means the first answer is 1. And the second answer is C over A. So that's C and this is A. So that's 7 over 3. That's special case 1. And if you have 5x squared minus plus 8x plus 3 equals 0. Now, 5 plus 8 minus plus 3 is not 0, but 5 minus 8, if you change the second sign, plus 3 is 0. It is 0, so it is a special case 2. It's a special case 2. And that means x1 is negative 1, and x2 is minus c over a. So that's minus c over a. So minus 3 over 5. Does anyone who was a no now a yes? Can you change the answer? Special cases can save you valuable minutes in any exam. And you begin to notice, once you get it, you begin to notice them and you just go, oh, I know the solution. So you can instantly solve quadratics, even faster than by factorization. Vieta's theorem can also be used to find quadratic equations with given roots. So if we write down a quadratic equation with the root 3 and minus 4, well, we know that if x1 is 3 and x2 is negative 4, and we know that x1 plus x2 is minus b over a, and x1 times x2 is c over a if you multiply them. Now, well, x1 plus x2, that's minus b over a. That is minus 1, because 3 plus minus 4 is minus 1. And c over a is the product, which is negative 12. So from here, we can say that b is equal to a. If we multiply by both sides by negative a, it's b minus a equals a. And from here, we can say that c is equal to negative 12a. Now, this looks like simultaneous equations, but with 3 unknowns, a, b, and c. But actually, let's write down. So the quadratic equation, ax squared plus bx plus c equals 0. So ax squared, we know that b is a plus ax, and c is minus 12. Minus 12a equals 0. And then we divide by a. And the quadratic equation becomes x squared plus x minus 12 equals 0. Now, you will realize that it doesn't matter what a is. It doesn't matter what a is, as long as it's not 0. Well, a is not 0, of course. Because a could be anything. You can multiply an equation by anything, you get the same equation, right? Because the roots don't change if you multiply an equation by something. Therefore, we can always assume, a A is 1. Okay, so how does that work? Well, because if you do ax squared plus bx plus c equals 0, you can always divide by a, and you get x squared plus b over a x plus c over a equals 0. Okay, and the next one, well, x1 is root 3, x2 is negative root 3. And that means x1 plus x2 is 0. So that is minus b over a, but we're already, okay, we can say that a is 1, b over 1. And x1 times x2 is root 3 times minus root 3, so negative 3. And that's c over 1, right? Because a equals 1. And here, so we can see that b is 0, c is negative 3, and a is 1. So the quadratic equation becomes ax squared plus bx plus c equals 0. So the quadratic equation is what x squared plus 0 plus 3, so minus 3 equals 0. So this is the quadratic equation with the given roots. Okay, so here x1 is 2 plus root 7, and x2 is 2 minus root 7. You add them. So x1 plus x2 is minus b over a. So that's minus b over 1. And if you add them, it's 2 plus root 7 plus 2 minus root 7 equals minus b. So so 4 equals minus b. So b equals negative 4. And x1 times x2 equals c over a, which is c over 1, which is just c. And that's equal to 2 plus root 7 multiplied by 2 minus root 7 equals c. So let's open the bracket. So 2 times 2 is 4, minus 2 root 7 plus 2 root 7 minus 7. So this cancels, and that's c. So c is negative 3. And we get the quadratic equation is x squared minus 4x minus 3 equals 0. Okay, and finally, we get this one. So this is going to be interesting because previously the quadratics did not contain any surds in the equation itself. So here, x1 times x2. So c is this. Once again, we can assume that a is 1 because a does not change the roots. So if you, yeah. So root 2 times 1 minus root 3. So that's going to be root 2 minus root 6. Then b minus b is x1 plus x2. And root 2 plus 1 minus root 3. So 1 plus root 2 minus root 3, same. Doesn't, oh, and then b would be root 3 minus root 2 minus 1. Okay, and now we can write down the equation because we know c, we know b, we know a. So x squared plus root 3 minus root 2 minus 1, x plus root 2 minus root 6 equals 0. Okay. I think today's webinar is a little bit on the harder side compared to the previous one. So if you're finding this hard to follow, please do watch the previous webinars. I've shown you where to find them. How is A assumed to be 1? That's a good question. Take any quadratic equation, like 3x squared plus 17x minus 29, whatever. A is not 1, but it's equal to 0. Let's divide by 3. And now we get a quadratic equation plus 17 thirds x minus 29 thirds equals 0. This quadratic equation has the same roots as the one above. So these are identical. These are identical. So if A is not 1, you can always make it 1. If A is not 1, you can make it 1. Does that answer your question? Hopefully. So yeah, if A is not equal to 1, you just divide by that number and then it becomes 1. The previous webinar was cancelled, unfortunately, so there wasn't any webinar. So I will do that webinar in 2 weeks' time. The webinars are published the same day normally, unless I mess something up and I need to revamp the video, like redo the sound or something, or cut the video, edit it. Usually it's within 2 hours after the webinar. Perfect. We'll answer the remaining questions later on. Right. Completing the square. The next is a very powerful tool dealing with quadratics, which you need to be very confident. Completing the square by recognition. So what does that mean? Well, let's have a look. X plus 1 squared. Well, we know that x plus 1 squared, you can open the brackets and you get x squared plus 2x plus 1. Then x plus 2 squared is x squared plus 4x plus 4. X plus 3 squared is x squared plus 6x plus 9. I promise I will stop at some point. 4 squared equals x squared plus 8x plus 16. And the list goes on forever, right? So x plus any number. A is a bad number to use. X plus, let's call it, which number is, okay, x plus a capital, so we don't get confused, is x squared plus 2ax plus a squared, right? Now, if you have, so how to do it by recognition? Example. If you have x squared plus 6x plus 12, for example. S squared plus 6x plus 12. Well, look, I recognized it. That's why it's called by recognition. It's this one. It's almost this one. It's almost this one, except it has a 12 instead of a 9. So we force it to, we say, well, that's actually x squared plus 6x plus 9 plus 3. And this thing, we already know it's this. So it's x plus 3 squared plus 3. So this thing is called a complete square. Completed square. Completed square. We've made the square complete. Right. Now, another example. X squared plus 4x plus 9. Now that looks like the second one, x squared plus 4x plus 4. So we make it x squared plus 4x plus 4. And that's a complete square plus 5, because we need a 5 to make 9. So that therefore it's x plus 2 squared is 5. That's it. Simple. X squared. Now if it's a minus, it will be a minus here. So plus or minus, plus or minus. So x squared minus 8x plus 2. Well, it's the fourth one. So that's x squared minus 8x plus 16. We need 16. But there's a minus plus 2, so minus 14. So we compensate to get 2, because 16 minus 14 is 2. So effectively what we're doing, we're saying instead of 2, we write 16 minus 14. And that completes the square. So that's x minus 4 squared minus 14. Right. So this is the completed square form. Now, of course, there's a formula. And you can use that formula. So the formula looks like this. X squared plus bx plus c. I'm omitting the a because a is assumed to be 1. Because you can always make it 1 by factoring it out. Little bit on that later. So you have x plus b over 2 squared minus b over 2 squared plus c. That's the formula that you can use to complete the square. I won't prove it, just believe it for now. So how to use this formula? Well, for example, we have x squared minus 4x plus 4x plus 17. So b is 4, and c is 17. So that's x plus b over 2, so 4 over 2 squared, minus 4 over 2 squared plus 17. So you get x plus 2 squared minus 4 plus 17, which is x plus 2 squared plus 13. Now, this is nice, except why would you use this method if you can do it by recognition, right? You could use this you could recognize that it's the second one. It's the second pattern. But where it becomes really useful is when you have odd numbers. So you have x squared plus 3x plus 9. Then you need this method. So you have x plus 3 over 2 squared minus 3 over 2 squared plus 9, and that becomes x plus 3 over 2 squared minus 3 over 2 squared. That's 9 over 4. 9 over 4 plus, well, 9 is 36 over 4. So write it down. 36 minus 9 is 27. So that's x plus 3 over 2 squared plus 27 over 4. So that's the completed square. So a little bit harder to do it by recognition. It's still possible. You just need to know that what 3 over 2 squared is and see it straight away. And of course, finally, let's look at an example where a is not 1. So 7x squared plus 4x plus 2. Now what you want to do is you want to take the 7 out. 7, I use square brackets. So x squared plus 4 over 7x plus 2 over 7. And I kind of forget. I forget about. Oh, I forget about the 7. And I say, okay, so 7. All right. I'm only interested in what's happening inside the brackets. So here I have x plus b over 2. So b over 2, 4 over 7 divided by 2, that's 2 over 7 squared minus 2 over 7 squared plus 2 over 7. Nice. So that's 7 bracket x plus 2/7 squared minus 4/49 plus 2/7. 2/7 is 14/49. And then I can say, well, 10 minus, that's 10. So, and I open the brackets. I multiply 7 by that and 7 by that. So that's 7 x plus 2/7 squared plus 10/49 times 7. So that's 10/7. And that's it. Yeah, that's a completed square. 1702. What? I thought the deadline for the first assignment was the 5th of October. Yes, it is. Um, okay. Right. Okay, there's another formula which is not very useful because it's quite hard to remember. Like, I mean, it says there's a formula for the case where A is not 1, but I've just shown you what to do when A is not 1. You just factor A out, right? Because, well, you could use it. Let's try using this formula. And I honestly have never used it because it's just too awkward. But let's see if we can get the same result. So it is A, so 7, open bracket, x plus b over 2a, so 4 over 14, so 7 over 2 squared, minus b squared, so 16 over 4 times 16 over 28. 16 over 28, that's 4 over 7. 4 over 7 plus 2. And 2 is 14 over 7. Oh, so 7x plus 7 over 2 squared plus minus, no, plus 10 over 7. Okay, using the formula is not that hard. Memorizing it, it's a whole other story. Yeah, I wouldn't. I mean, if you challenge me, of course I can remember this formula, but I'd rather be able to. I can prove that I can derive that formula in under 3 minutes probably, but I just can. I don't see any value in remembering it. Okay. Problem 6. Now we're talking about the discriminant, and the discriminant is that thing. The discriminant is that thing when you do the quadratic equation. So discriminant. If you have x squared plus bx plus c equals 0, the discriminant d is b squared minus 4ac. You've seen it before. You've seen that in the quadratic formula, minus b plus or minus square root of b squared minus 4ac divided by 2a. So the quadratic formula is sometimes written as minus b plus minus square root of d over 2a. So d is that thing, b squared minus 4ac. So if b squared minus 4ac is greater than 0, then you have two roots, two distinct roots. If b squared minus 4ac is 0, then you have one root, or sometimes called repeat roots. Repeat roots. Then if b squared minus 4ac is less than 0, if the discriminant is less than 0, then you have no roots, no real roots. And the question is, for what values of q? So this is a quadratic equation, but the third coefficient is unknown. For what values of the parameter q does the quadratic equation have exactly one root? Okay, so the equation has exactly one root if the discriminant is 0. So discriminant, which is b squared minus 4ac, must equal to 0. In order for the quadratic equation to have one root, the discriminant must equal to 0. So we have discriminant is b squared, so minus 3 squared minus 4 multiplied by 2 multiplied by q must equal 0. So 9 minus 8q is 0. So 8q is 9. So q is 9 over 8. That's it. So if q is 9 over 8, then this quadratic equation has exactly one root. Cool. Now the second one. Now this one is a little bit tricky because you must understand that a quadratic equation has exactly one root if the discriminant is 0. So this rule only works if you have a quadratic equation. So you must check what happens if the equation stops being a quadratic equation. So here, this is a quadratic equation. Well, it's not always a quadratic equation because sometimes it isn't. What if q is 0? If q is 0, then this is 0. And it's not a quadratic equation. It's something that we call a linear equation. So there are two options. Option 1 is the discriminant is 0, or equation is not quadratic. So if discriminant is 0, so let's do that bit. So b squared minus 4ac is 0. That means b. So q plus 3 squared minus 4 times q times c, which is -1, is 0. So q squared plus 6q plus 9 minus plus 8 plus 4q equals 0. Q squared plus 10q plus 9 equals 0. And that means, well, it's a special case 1. Lovely. It's a special case, special case 2. So Q1 is -1 and Q2 is -9. You see, special cases are very handy. And okay, equation is not quadratic. So when is the equation not quadratic? When if q is 0. If q is 0, the equation is not quadratic. So it becomes 0 plus 3. So 0 plus 0x squared plus 0 plus 3 x minus 1 equals 0. So we have 0 plus 3 is 3. 3x minus 1 is 0. X equals 1/3, so one solution. Okay, so answer. One solution if q is -1, q is -9, and q3 is 0. So either in three cases. This is called an equation with a parameter. There'll be lots of these. Yeah. Okay, number 9, graph of a quadratic function. So let's have a look. Y equals ax squared plus bx plus c. This is a quadratic function. And ooh, okay. Um, well, okay. I'll go Desmos. Desmos. So y equals ax squared plus bx plus c. Right. So here is Mr. Desmos, and we're allowed to change the parameters. So what happens if we change a? Well, like, the parabola becomes narrower and wider, and it can flip upside down. So something interesting happens when a equals 0. The parabola becomes a straight line. Oh yeah, because it's not a quadratic anymore. It's a straight line. So the bigger the a, the narrower it is. Closer to 0, the wider it is. And the more negative it is, it's upside down and narrow. Okay, it's quite difficult to figure out what exactly the parameters do. So I recommend you trying this out, just seeing for yourself what happens. If I change b, you can see that the parabola moves, but it's not very helpful to, like, if b is 7, for example, what does that mean? Well, we don't really know because b doesn't have a strict meaning. Well, c does. C moves the parabola up and down. That's like the easiest one, the easiest parameter. So you can always say if C is 4, we know that the parabola meets the y-axis at 4. If C is 10, we know that it meets the y-axis at 10. Okay, so C is the y-intercept. That's easy. But B, not really clear what B is, and A is just the shape. Okay, A is the shape. It's reasonably easy to figure out what A is, but B just like it's an awkward one. That's why we don't when we draw parabolas, we don't use this. We don't use this form. Any parabola can be written as this is the standard form. A x minus h squared plus k. This is a much better way of writing. This is the completed square form. Completed square form. Well, we know that any parabola, any quadratic can be written in the completed square form. So we can write this down. So y equals a, open bracket, x minus h squared plus k, and we add the sliders. So you can see that, well, changing a changes the shape of the parabola. Okay, that's fine. Let's make it 1. Now, changing h moves the parabola horizontally. Oh, that's much more control over the parabola. And k moves the parabola vertically. Oh, this is just lovely. Look, if I make kh 5, you can see that the vertex, the lowest point of the parabola, is at 5. And k, if I make it 1, for example, then the vertex is 5, 1. Look, 5, 1, h is 5, k is 1, the vertex is at 5, 1. If I make h minus 4.7 and k 3.3, minus 4.7, 3.3. So This is incredibly useful because if you write the parabola in completed square form, you immediately know the vertex. And changing A doesn't change the vertex. Look, changing A just changes the shape of the parabola. Okay. And finally, the third form. So here, H and K. HK is the coordinate of the vertex of the turning point. And finally, we get this form: y equals a x minus x1 x minus x2, which x1 and x2 are already familiar to you. These are the roots. Let's call them x minus y equals a x minus p x minus q. Right. So if p is 1 and q is 1, then we have one root. If p is, I don't know, minus 3, and q is 1, you can see that the parabola passes through these 2 points. These are the roots. And if I were to change a, the parabola would change shape, but it would still go through these points. So that's quite neat. So you can always rely on this. You can rely that x1 and x2, x1 and x2, x2. So x1 and x2 are the x-intercepts. So how to use these three forms? Well, let's say you work out the equation of the following parabolas. So what do you know about this parabola? Well, you don't know what that is, right? It looks like 4.5, but minus what? But you can definitely see that this is 2 and this is 7. So this is x1 and this is x2. So we're going to use the third form of the parabola. We're going to go y equals a x minus x1 x minus x2. So y is a x minus 2 x minus 7. To find a, use any other point. So to find a point, so I'm going to go with this one, 1, 3. So x equals 1, y equals 3. And we sub that in into our equation. And we get 3 equals a multiplied by 1 minus 2 multiplied by 1 minus 7. And so that 3 equals a multiplied by minus 1 multiplied by minus 6. So a is a half. Therefore, the final equation becomes y equals a half x minus 2 x minus 7. Yep, and we can open the brackets. Y equals 1/2 x squared minus 2x minus 7x plus 14. Y equals a half x squared minus 9x plus 14. Open brackets. Y equals 1/2 x squared minus 9 over 2x plus 7. And that's the equation of that parabola. And you can also check that 7, remember, we said that 7 is the y-intercept. And it is 7. Ta-da. 7, 0. Brilliant. Can also use that one. Okay, the next one. Next, you can see the parabola, but these points are unknown. So I wouldn't use these 2 points. I would use the vertex. And I would use, so this is 4 minus 3, 4 minus 3. And this is h and k. And I remember the form y equals a x minus h squared plus k. So y is a, open bracket, x minus 4 squared minus 3. And once again, to find a, use any point. So I'm going to use 2, 1. Use 2, 1. So 1 equals a multiplied by 2 minus 4 squared minus 3. And I get 1 equals 2 minus 4, that's minus 2 squared is 4a minus 3. 4a equals 4, a equals 1. Nice. So the equation y equals x minus 4 squared minus 3. But we want to open the brackets, so we get y equals x squared minus 8x plus 16 minus 3, y equals x squared minus 8x plus 13. And that's the equation of the parabola. That's the answer. Okay. So, yes, when you see a parabola, you need to check. Can you find the x-intercepts? Then you can use this formula. Or if you can't find the x-intercepts, or they are not whole numbers, you can use the vertex. If you can't use either, well, use any 3 points. You can always use any 3 points. It's a little bit, it's long, but it's doable. So here, again, vertex is minus 3, minus 2. It doesn't cross the x-axis at all. That's an interesting one. All right, so we're going to use y equals a x minus h plus squared plus k. So h is this, k is this. So y is a x plus 3 squared minus 2. Now we still don't know a. To find a, we use this point, minus 2 minus 4. And so minus 2 minus 4 to find a. So we got minus 4 equals a, open bracket, minus 2 plus 3 squared minus 2. Minus 4 equals a minus 2. A is negative 2. Right, so y is negative 2, x plus 3 squared minus 2. Y equals negative 2, x squared plus 6x plus 9 minus 2. Y equals negative 2x squared, negative 12x, negative 18, negative 2. Y equals negative 2x squared minus 2x minus 20. That's the equation of the parabola. Perfect. Brilliant. I hope that helped. Now, once again, today's webinar was slightly on the harder side, and I was quite rushing through some of the questions. So I think last year I did a much slower, down-to-earth webinar, so you can have a look at that. It's webinar 2 from last year. The webinars can be found on our COMPOS website. So you go about COMPOS, webinars. So you can check all COMPOS webinars. These are the recordings. If you click on that, you can check the recordings from last year. Now I'll answer the questions. Are we okay to check our answers with math solving tools? I think Arian has a better answer. Yes. So it is an entrance exam. So we expect the solutions to be your own, not based on any math solving tools. If you want to use Desmos to check your answers, by all means, but definitely not like AI or something like that. Yep. It will be higher score. Yes. When this webinar uploaded in the next hour or so, maybe straight away. Do we have to create a separate answer sheet when submitting our answers? Well, I don't think you can. I don't think it's possible to write the answers on our printed out sheets. We expect you to do your test on paper, and just problem one, and then you'll take a photograph of problem one and you'll upload it. Instructions will be sent. Instructions will be sent to you by email. And the deadline, I think it's the 5th of October. Pretty sure. Yes, the 5th of October. The 18th of October is just cancelled. We just look out for the next one. It's the 15th of September, and it's going to be the same topic. So I was planning to do 2 webinars on that topic. Well, I'll just do one, but hopefully that won't be enough, especially if you have the recordings from last year. Okay, well, I hope that was useful and was well, good luck in your first assignment, aka entrance test, and hope to see you in 2 weeks' time for the second webinar. Of course, you can leave some questions unanswered. That's perfectly fine. Okay. All right. Right. Bye, everyone. Thank you, Ariane.